spirit at least. All right, so we are now at the point in the meeting where Joseph O'Connor is going to not talk about his robot car. I guess, he had demoitis, but before the fact. And I understood this effect where your thing that was supposed to be working just fine was supposed to conk out in the middle of the demo rather than shortly before. But
It actually did conk out in the middle of the demo a couple of times.
not not that we saw. So anyway,
I was
having
I was
problems with his
clever.
car. We're going to talk about defining words. And Joseph, introduce yourself and tell us what you're going to say.
Okay. Hi, my name is Joseph O'Connor. I've been a member of the Fourth Interest Group for a very long time. Um, I'm here to talk today, instead of talking about the PIC RX, to talk about a um, some details of my own version of Fourth that I came up with. The title of the talk is, let me scare up my screen, Compiling and Defining Words in Creole Fourth. So I'm going to share my screen. Okay, can everyone see that?
Yes.
Okay, good. I'll get started. Okay, um, this is the overview of my presentation today. Um, First, we'll talk about defining words. They have two actions, one at compile time and another at runtime. Compiling words, they execute at compile time, usually for the purposes of generating code into the parameter field. In both cases, there's a difference between compile time code and runtime code, which can be tricky to visualize. So here are the quintessential defining words. I think almost everybody who works regularly with Fourth is seeing this. So creating a constant and a variable. Um, I know the NOP doesn't ordinarily go there. That means no operation. Usually when I see variable defined, it's create space, comma, but this works just the same. Some compiling word examples, do loop and loop plus executes code in between a definite number of times. Begin until it executes code in between until some specified condition is met. If, else, and then conditional execution. Some points to remember. Defining words and compiling words both have separate compile time and runtime actions. Compiling words are used most often when setting up control structures. Defining words are a method of creating a new compiler. And some consider defining words to be an early form of object-oriented programming due to words inheriting functionality from previously defined words and the grouping of data and functionality together. So this is an example of constant. That's the code for it in Creole Fourth. So we have to deal with three separate times. First, compile time. Tokens for the primitives do create, do comma, compile does, and do fetch are placed in the parameter field. Compile time 2, that's when a constant is defined. So I have 3 constant 3. It compiles 3 into the parameter field, followed by its own address token and the runtime code. The code is set to do does. Code field is set to do does. Runtime, it puts the index field of the current word onto the stack, has do colon execute fetch. This retrieves a value in the first member of the parameter field, which is 3, and then pushes it onto the stack. For the compiling words example, I'm going to just stick to if, else, and then for the purposes of keeping this presentation short. So you have compile time. First, the compile if statement. It adds the zero branch code and a placeholder -1 to store the address to jump to. Next, it pushes the location of the placeholder onto the stack. Compile else next adds the jump primitive and the -1 placeholder next to it. It pops the position of the zero branch address to jump to off the stack, stores the location to jump to in that position, concludes with pushing the jump address location next to the jump command onto the stack. Next, compile then. It pops the location information off the stack and puts it in the -1 placeholder that we made and adds a do then. Finally, in runtime, do zero branch jumps to the address beside it if it consumes a 0 value, otherwise just advances the parameter field pointer by 1. Do else and do then are synonyms for do not, no operation. Their location is what's important, not what they do. So I realize that's a lot to unpack. Um, if else then, that's one of the simpler um, sets of compiling words. But as you can see, understanding it is a little bit complicated. So I've made up a table where I show the Python method in Creole 4th for Python, the dictionary definition, the contents of the parameter field after it executes, and then what's on the stack. So when I have compile if, this is the code that's put into the parameter field, zero branch and -1. It's actually the token that corresponds to zero branch, not zero branch itself, but I think you get the idea. Do hello. So that's just compiled into the next entry into the parameter field. Oops, I'm sorry. When it hits compile else, it takes location 1 as a parameter and it returns location 2 as a parameter. So this is what the contents of the parameter field look like. So this location is popped off the stack, and then the address to jump to 0, 1, 2, 3, 4, 5 do else is put in. And then so you have jump -1 do else. Then tulip is compiled next. That just pops up a message saying tulip, by the way. So this is what you have then. Tulip is just, since it's not an immediate word, it's just compiled into the next entry into the parameter field. 4 is still on the stack. 0, 1, 2, 3, 4. That's the location of the -1. Compile then. Do then is then put, and the stack is emptied. And then semi, here are the final tokens in the parameter field. Okay. This also pops the immediate vocabulary off the stack. It terminates compilation. Creole fourth compiling words, there's some differences from most force. Most force define a state variable to differentiate between compiling and not compiling. A word that is marked immediate will execute during compilation. It won't compile. Creole fourth lacks a state variable. Instead, all immediate words are in the immediate vocabulary. During compilation, the immediate vocabulary is placed on top of the vocabulary stock. Therefore, this vocabulary is always searched first. At the end of compilation, the immediate vocabulary is knocked off the vocabulary stack, which makes the words in that vocabulary inaccessible afterwards. So during normal interpretation, they cannot be accessed. Creole fourth colon compiler. The definitions are built into the pad data structure. Each word in the definition is looked up. The fully qualified name, which is the name plus the vocabulary, token or address, and compile time action are placed into a compile info object. So that has those 3 pieces of information. For ordinary words, the compile time action is comp in PF, which is a synonym for comma. For compiling words, this action is execute. Once the name, token, action triplets are all in pad, the respective tokens and actions are passed to an interpreter. It isn't the one that is currently running, it's another one. Each token is pushed onto the stack, then consumed by the compile time action. So this is if, then, else in pad, or the nearest approximation that I can get. So the fully qualified name, the token address, and the compiler action, compilation action in pad. So if has an execute compilation action because it's an immediate word. Hello has a comp in PF because it's not an immediate word. Else has an execute action. Tulip has a comp in PF action, then execute action, and semi has an execute action. Some final observations. The more recent versions of Creole Fourth for Python, Visual Basic, etc., they appear to blur the distinction between compilation and meta-compilation. In a meta-compilation loop, each symbol encountered is first executed, not compiled. This execution causes to compile its target compilation address into its target. In Creole Fourth, each token in pad is executed by its compilation action, which is embedded in its definition. Ordinary words have their tokens placed as is in the parameter field. So let's say the word hello, it has the token of 5. So that's just placed as is in the parameter field. compiling words are executed, which generates code into the parameter field. In principle, it could generate code anywhere. So this setup may offer advantages in modularity over a single global compilation process with a state variable. Finally, questions, comments?
I like your use of vocabularies in terms of transitioning in and out of uh, compilation.
Thank
This
you.
is the snazziest last minute thrown together talk I've seen ever. Send your slides on to Dave so that he can
Will
include
do.
them on the website.
Okay.
Uh,
Yeah, Brad, I got the idea from reading Jeff Fox's website and also Martin Tracy's book. So we talked about meta compilation. He also talked about the vocabulary stack, but Bill said that that was his idea. Um, Martin didn't mention that.
Cool.
Anyone else? All right, let's move on. I goofed up the schedule. I've got too much other stuff going on in my brain. It's starting to leak out in my ears and make a terrible stain on my shirt. Brad Nelson, uh, you're up. Introduce yourself and tell us what you came to tell us. Joseph, would you unshare your screen?
Yep. Share. Um,
I'm hoping Brad will unmute sometime before I start speaking.
All right. Can